Friends, in special case, let limit extends to c fx by gx takes 0 by 0 form. Okay, 0 by 0 form. So since many common functions have continuous derivatives, as for example polynomials, sine, cosine, exponential, logarithmic function, in special case let us consider the function fx and gx continuously differentiable at the point c where finite limit is found after the first derivative. Let us consider that fc is equal to gc is equal to 0 and g dash c is not is equal to 0. Then limit extends to c fx by gx is equal to limit extends to c fx minus 0, we can express this way, divided by gx minus 0. So this is equal to limit extends to c fx minus 0. What is 0? 0 is equal to fc. So this, replace the 0 by fc divided by gx minus 0. 0 is equal to gc, g of c. So friends, we write limit extends to c fx minus fc divided by x minus c, okay, divided by gx minus gc divided by x minus c. The point is c. So we divide both numerator and denominator by x minus c. Okay. So from this one we get limit extends to c fx minus fc divided by x minus c is f dash c using the definition of derivative, and limit extends to c of gx minus gc divided by x minus c is g dash c. Okay, so we find limit extends to c fx by gx is equal to f dash c divided by g dash c. That means limit extends to c of f dash x divided by g dash x. Since fx and gx are continuously differentiable at x is equal to c, so we can write this expression in this way also. The general proof of L'Hospital rule is given by Cauchy's mean value theorem. Now friends, we illustrate one example. Friends, let fx be a twice differentiable function and f double dash 0 is equal to 2. Then evaluate limit extends to 0, 2 times of fx minus 3 times of f of 2x plus f of 4x whole divided by x square. Obviously this limit has 0 by 0 form. Okay, this is also of 0 by 0 form. Why? See that f double dash 0 is equal to 2. So the original function fx is a combination of polynomial or sine or cosine or exponential or logarithmic function, so that fx in each term of fx should have x. So for this, when x tends to 0, then fx will tend to 0. So the numerator is tending to 0, simultaneously the denominator is also tending to 0. For this, the form is of 0 by 0. So friends, we easily use the L'Hospital's rule. L'Hospital's rules. So we find limit x tends to 0 twice of f dash x minus 3 into 2 f dash twice x plus 4 times of f dash 4x whole divided by twice x. Twice x is the derivative of the denominator x square. So this is equal to limit x tends to 0 twice of f double dash x. Again we differentiate this one because this is again in the 0 by 0 form. So since it is given that f double dash 0 is equal to 2, so in the first derivative also you will find the numerator is tending to 0, simultaneously the denominator is also tending to 0. since x tends to 0. So twice of f double dash x minus 12 times of f double dash twice x plus 4 for the 16 f double dash 4x whole divided by 2. 2 is the derivative of the denominator twice x. So friends, this is equal to limit x tends to 0. 2 times of f double dash 0 is equal to 2. So f double dash 0 is equal to 2. So we withdraw this limit, okay? We withdraw this limit. So we shall find 2 times of 2 minus 12 times of 2 plus 16 times of 2 divided by 2. So we shall get this as 2 to the 4 minus 24 plus 32 whole divided by 2. This is equal to 32 plus 4, 36. 36 minus 24 means 12 divided by 2 is equal to 6. So using L'Hospital's rule, we found the limit x tends to 0 of this expression as equal to 6.